Hi everyone, I'm Vinesh. I'm from Instacart. Nice to meet you all. Today I'm going to talk to you a little bit about what we have done at Search at Instacart, and sort of walk you through some of the times when we were pre-pandemic, through the pandemic, and then now, because it was definitely a quite a change in how customers perceived Instacart. Maybe to tell a little bit about myself, I'm currently a member of the search team. I lead the ranking team within the search and discovery group at Instacart. Um, so, our focus is on building the machine learning models that power things like user intent understanding, neural text modeling, and also incorporating multi objective ranking into our overall search results. And also for those of you who probably don't know what Instacart is, we are currently the leader in North America in online groceries, both for pickup and deliveries. And maybe just to talk about our vision, I guess it's to create a world where everyone gets to enjoy the food they love and have a lot of time doing that. All right, so moving on. So today, what I'd like to talk about is give you a high-level overview of Instacart search. Talk about some of the problems and the challenges that we face, and then, time permitting, I would like to walk you through a couple of use cases that we've tried to solve to address some of those challenges, and then go over any lessons learned from our experience. So this is what it looks like today. Like most modern search engines, we have three main components: the query understanding layer, the retrieval, and then the ranking. So the query understanding layer is the one that tries to understand the user intent and builds some personalized intent recognition that's then used to power our retrieval layer. So as you can see, the retrieval layer, it looks a bit complex here, but essentially it's just a combination of keyword retrieval in the catalog store, and then embedding retrieval using Facebook's Fice library. And then once we get a set of results, we sort of go through a set of ranking stages, which is where we try to apply some multi-objective ranking paradigms to generate the final search results page. So there are a bunch of models interspersed through all of these various components, and I'll sort of walk you through each of those. Um, so just talking a little bit more about the scale of our data, right? I think one of the challenges that we have faced at Instacart is that we have a very diverse marketplace. We are trying to support retailers, both national and local, on the platform. So this essentially lends itself to sort of supporting 70,000 stores across most major cities in the US. And this also adds up to around a billion products. Now, while a billion products is not really massive in today's e-commerce world, what's challenging for Instacart specifically is that we have a lot of diverse retailers. So while there are maybe retailers like Safeway, where you have a lot of inventory, and then you might have niche retailers like 99 Ranch Market, which is an Asian retailer. So the same query, like for example, snacks, means very different things in Safeway versus maybe a more niche retailer. So this long tail of retailers and queries is where the challenge is at for us. And yeah, since 2020, after the pandemic, is when all of this also started to explode, both in terms of the query distribution and also the number of retailers who want to be on the platform. Um, and so while data is one side of the problem, the other set of challenges that we have had are that I already spoke about the heterogeneity among the retailers. Trying to generalize across these retailers is one problem. The second is just a general cold start problem, which is common across a lot of e-commerce kind of websites. Specifically, while uh, while for head queries and even maybe for torso queries, we have enough data to sort of rank items using user engagement data. It's sort of hard to sort of rank the long tail of items and also address and retrieve items well for the long tail of queries. So that's where the cold start problem comes in. And then users come in with a wide variety of needs, right? I mean, some users have very clear intent. They're here for just their grocery shopping and then be done with it. Whereas some others are maybe coming in to plan a party, or do some or cook something fun for the weekend. So trying to understand the user requirements from their queries, trying to guide them through that journey is another challenge. And then the last is Instacart is a marketplace. That means that we are trying to balance the user's goals, the retailer's goals versus the overall platform's goals, which is to maximize revenue. So trying to do all of that within our search results page is probably where we have sort of tried to tackle um, the major problems over the last year. So I'll probably walk you through a couple of use cases of how we have tried to do that. The first is, so we trained a deep learning model to sort of model queries and products in the same representation space. And the main reason for doing this was we had as I mentioned earlier, we had a cold start problem. We could very easily use existing search log impressions, etc., to do well for the head and torso queries. But then for our long tail of queries, we didn't really have uh, a good recall nor even ranking. So as you can see in this chart on the right, basically after a certain number of items, let's say the top 100 items, I mean, there's a steep fall off in the data that we have for products, as can be seen by the CTR feature there. CTR is essentially the click-through rate. So what we did was to train a two-tower model to sort of learn a representation for the user, for the queries and the products in the same space. And what that allowed us to do was, by taking a dot product of these learned embeddings, we now had a measure of the relevance of the product to the query. Whereas earlier we were relying primarily on user engagement data, now we could apply this for products that were never seen before as well. So essentially, it was a way to semantically rank products that were relevant for a given query. So yeah, this was the work was presented at SIGIR as well. So yeah, you can find the paper online. And the main takeaway, I guess, from this, I would say, is that uh, given that we sort of had this the retailer problem, wherein we had different products across different retailers meaning different things, building an embedding model that sort of generalized across retailers was really helpful in giving us a leg up in developing semantic search solutions. The other thing I'd also add here is that um, we are also trying to add retailer information now to the query tower. So doing that is also showing promising results because that allows us to capture an additional dimension in the user query itself. Moving on, I think the second use case I just wanted to touch upon was how we have tried to use autocomplete in the overall user's journey. Um, as I mentioned earlier, we have multiple goals, the retailer versus the platform versus the user goals. Trying to sort of balance these different objectives means that we've sort of a few different levers to do that. And one of the levers that we tried to use here was autocomplete. Now, autocomplete sort of is a way to make a user search journey more efficient. And initially, that's how we started off. We used the search logs to build a popularity based model that, given a prefix, lists out a list of queries that users have typically searched for. And using search logs meant that we had rich natural language queries that would make sense to the user. And that's what the initial model also showed. Um, so then we sort of moved on to maybe trying something more advanced. As the popularity of autocomplete grew, we thought, could we maybe use this to guide a user's journey while they build their cart? Could we maybe drive for more discovery? or could we inspire a user to try out something new that they haven't seen before? So that was the thing that we started off on. And so while the original autocomplete model was primarily focused on improving user engagement using various features like um, the prefix to query engagement features, popularity features, etc. Uh, we then moved on to this multi-objective kind of paradigm wherein we tried to optimize for two different things. The engagement with the autocomplete suggestions and the subsequent engagement with the results for that autocomplete suggestion. So in this case, it's basically breaking it down into two parts, right? One is the autocomplete engagement model, which is modeling the probability of the user converting on the term given that prefix. And then the next part is, does the user actually add an item to their cart once they clicked into that term? So this was a very simple way we used to sort of break down the multi-objective problem into individual models. And then by training individual models, we were able to quickly show improvements in both engagement rate and our add to cart metric. So we are now looking at maybe some models on top of this that tries to balance different objectives using contextual bandits. But yeah, that's probably a topic for later. So so what's the key takeaway here? I think we sort of used autocomplete as one way to sort of guide users through their journey, while also balancing for the different requirements of the platform, which is to once again maximize the user satisfaction rate, while also allowing retailers to push for more novel and, let's say, discovery themed products. So that I think the main reason for trying to do this is that there's a clear correlation between users' engagement with more diverse products and their engagement on the platform. So this was a way for us to sort of balance these different objectives. All right. So moving on. So while we built out these different models, we spoke about just a couple here: the autocomplete and the embedding model. We faced a number of operational challenges trying to productionize this, especially as the traffic increased through 2020 and 2021. At a very high level, the things that I'll probably talk about today are data quality. So data quality here is actually a very broad term. It encompasses things like just all of the attributes in our catalog itself. Like, for example, the prices of the items, the weights or the dietary attributes associated with an item. A lot of these are provided to us by the retailer, but we need to have our own models to sort of ensure that the data is accurate. Because quite a few times I've had cases where an item that isn't gluten-free is marked gluten-free or vice versa. And this could be a problem for users who may not read the label closely. So it's on us to sort of ensure that the quality of the data on the products is good. So while it's not exactly the search team's responsibility, we have still sort of had to invest in, or Instacart as a whole has had to invest in models to sort of extract these attributes and with high precision. Like, for example, even as something as simple as this, which sort of is like a non-dairy ice cream, is something that we don't actually get the proper labels from the retailer. So it's something that we need to parse. So this is an area that we have had to invest in. Apart from that, given that our service grew a lot over the last 2 years, our architecture has also had to evolve along with that. While we started off with a very monolithic architecture where there's a single ML service with some batch predictions, which led to a number of problems, as I'm sure you're all aware. Essentially, the monolithic service meant that code complexity increased a lot. And using batch predictions also meant that if any scoring jobs took a long time, then any failures in upstream or downstream would sort of result in a lot of effort in trying to get us back to parity. So that's where we sort of tried to move towards a more modular architecture, wherein we broke up the overall stack into different parts. As I mentioned earlier, the query understanding, the recall, and the ranking stages. And then we also started splitting out the actual inference part, the part where we store the features, into all of these different boxes. So along our journey towards this more modular architecture is where we realized that, hey, these are all common across Instacart, that maybe some of these things like building a real-time feature store, having an inference platform, a training platform is more generalizable. And that's where a lot of these things were then generalized into a more a platform across all of Instacart. So this is Griffin. Again, there's a blog about this where we sort of spoke about how we could use just off-the-shelf components like Snowflake, Databricks, Ray, etc., to put together a very easy-to-use platform for developers to quickly train models and then actually launch them in production. So this was really helpful for us in launching our models or getting our models from development into production much faster. So I think investment in a platform, while it's harder for earlier stage companies, I think it's definitely worth the effort to sort of scale up the overall modeling efforts. Yeah, I'll probably finish up with our lessons learned here. I think the main things that we sort of learned over the last 2 years are that I think it's really important to track the relevance of your results over time. So investing in efforts like human evaluation, etc., I think are really important. Using frameworks like the ACI to sort of measure relevance over time is also useful to see how well you're doing over time, and have an unbiased view of your ranking models, because survivor bias and selection bias are pretty important problems, which I can't go into right now. But I think having an unbiased view would help there. And the last thing is, yeah, I think tackling cold start was really important for us. Like building the embedding models to sort of tackle the long tail of queries was really helpful in both gaining users' trust and also in letting users discover new products, which I think is actually is a problem for retailers. And yeah, I think the last part is just around how it's important to have good monitoring. The one thing I'll probably leave you with is that one of the problems that Instacart has is that because of the number of retailers, we have a high dimensionality problem wherein uh, a small retailer in a specific location might be out of stock in a certain product, or they or maybe we are doing pretty poorly there because we are not somehow we are not tracking the data from those places or whatever. So having good monitoring that sort of allows us to dissect such high dimensional data is really important. So yeah, I think that's probably the last takeaway I would leave you with. Yeah, that's it. Thank you, everyone.